friends, today we shall start a new topic, gravitation. Gravitation, it is a type of force between any two bodies, and from ancient human beings were very interested that any body which is allowed to fall freely, it falls freely under gravity, that is, it is attracted towards the ground. Galileo studied the acceleration of the body towards the earth, and Copernicus studied the revolution of planets around the sun. Sun is at center and all planets are revolving around the sun. Tycho and Brahe, they observed with naked eyes the motion of planets around the sun. They spent their whole life in observation of the planets. And Kepler, he proposed three planetary laws of motion. And using the theories of all these scientists, Newton proposed gravitational law, that is universal gravitational law. And according to Newton's universal gravitational law, the force of attraction between any two bodies in the universe is directly proportional to the product of magnitude of the masses and inversely as the square of the distance between them. Consider two bodies of masses m1 and m2 separated by distance d, where d is the distance between the centers of two bodies. Then F is proportional to magnitude of m1 into m2 upon d square, or F is equal to g into m1 m2 upon d square, where g is universal gravitational constant and its value is 6.673 into 10 to the power minus 11 Newton meter square per kg square. And in vector form, Newton's law can be written as F vector is equal to g into m1 m2 upon d square into d cap, where d cap represents the unit vector in the direction of force. The force on first body due to second body is F12, it is acting towards second body, and force on second body due to first body, it is F21, it is in the direction of first body. Therefore, vector form can also be written as F1 vector F12 is equal to G m1 m2 upon d12 square into d21 cap, because force is acting in opposite direction. And if m1 is equal to m, the mass of earth, and m2 is equal to small m, it is the mass of object on the surface of earth, then the force between the object and the earth is given by F equal to g into m upon r square, where r is the radius of earth. R is the radius of Earth. The dimensional formula for G is -1 in mass, 3 in length and -2 in time. Then what are the properties of the gravitational force? There are some similar and dissimilar properties between electrostatic force, that is the force between charges, and gravitational force. It is always attractive in nature. Gravitational force is always attractive in nature, but electrostatic force may be attractive or repulsive depending on the nature of charges. And gravitational force is independent of the nature of the bodies. It is central force. Gravitational force always acts along the line joining their centers. Similarly, electrostatic force also a central force. And gravitational force is independent of the medium. That means gravitational force does not depend on the medium between these two bodies or the medium in which the bodies are placed. Gravitational forces, but electrostatic forces are dependent on the nature of medium in which they are placed. And gravitational force, it is mutual attractive force. That means the body 1 attracts the second body is equal to the force of attraction due to second body on first body. Force on first body due to second body is equal to force on second body due to first body. That is F12 is equal to minus F21. Here negative sign indicates that these forces are opposite in nature. Gravitational forces are the gravitational forces obeys inverse square law. Similarly, the electrostatic force also obeys inverse square law. And they valid for, gravitational forces are valid for point masses and electrostatic forces are valid for point charges. Then what is the significance of gravitational force? It is difficult to recognize the force between two bodies having small masses separated by small distances. Suppose the force between me and you, the masses are very small, therefore gravitational force is insignificant for lighter masses separated by smaller distances, because the value of universal gravitational constant is very small. It is of the order 10 raised to minus 11. Therefore, gravitational force exists between heavy bodies separated by infinite large distance. Clear? And the questions, main questions, 3 marks, 2 questions. They are: state and explain Newton's universal gravitational law. It states that the force of attraction between any two bodies in the universe is directly proportional to the product of magnitude of masses and inversely as the square of their distance. Then consider two masses m1, m2 separated by distance d. Then according to Newton's gravitational law, F is proportional to F is proportional to F is proportional to product of magnitude of two masses and inversely as the square of their distance, or F equal to G into m1 m2 upon d square. And in vector form it can be written as F vector equal to G into m1 m2 upon d square. Mention any three properties of universal gravitational force. It is always attractive in nature. It is central force. It is independent of the medium. It is mutual attractive force. It obeys inverse square law. It is valid for point masses. Then what is the significance of gravitational law? Gravitational force or gravitational law. Gravitational force exists between heavier bodies separated by infinite distance. It is insignificant for low masses separated by small distances. Thank you.